circuit is completed, how to see the waveform. Okay, simulation control, you put it 0.01. The standard value you fix it. Okay, 0.01 standard value you fix it. Okay, and then in the simulation, you just select V4 and see the waveform. Then you add the waveform one by one. First input you add. Okay, then second input you add, and the final selection line also you add. Okay, only this thing you have to remember. Only this thing you have to remember in the circuit, what values we are fixing. Simulation control 0.01. Simulation control 0.01. And the duty cycle for VA 0.5 and VB half of that. Anything you can go for VA, but VB half of that, so that 0001 1011 combination will come. Okay, so half of that means 0.225 is the duty cycle. Okay, so changing the names and all, it's optional. You can put D0, D1, I can put VA, VB, another person can put capital A, capital B as the input anyway. Okay, that is our individual choice. Next, the selection line, this duty cycle you can put either VA duty cycle or VB duty cycle, but our truth table should satisfy. When selection line is 0, first input should travel to the output. Selection line 1 means second input should travel to the output. You can check putting the duty cycle 0.25 also, you can get more clarity. Okay, duty cycle of V select can be anything of VA or VB. You can put duty cycle for V select same as either VA or VB. Okay, now I have changed it to 0.25. Waveform is already there. You can see here instead of 0.5, I changed selection line, duty cycle as 0.25. Now what happens? 2 times it will come, I think. So VA, then VB, whichever you select, that order the display will come. Okay, see that selection line comes in the bottom, so that for analyzing it will be easy. Then comes the first and second line here. Okay, you can see this portion, V select is 1. 1 means second input should come at the output. This is the second input. Okay, output is same as second input. Okay, and for all this time it is 0. Selection line is 0. Selection line 0 means first input should come at the output. This is our first input. Okay, it has come as the output. Now first input change it to 0. It has come at the output. Okay, I have shown you all possible ways to analyze the multiplexer. Circuit is very simple. We are taking multiplexer component directly, and 2 inputs, 1 selection line. We are giving square wave voltage source. We are giving the probes to see the waveform. Okay, probes are just to see the waveform. Output side, instead of floating, we have given some resistor and a probe to see the output waveform. Simulation control is just to mention how long the circuit should execute. Okay, how long circuit should execute. Without giving voltage probe, after simulation, you will not get waveform window. If I remove all the voltage probes and I simulate, I will not get the waveform window. Only probes are there, whether current probe or voltage probe you keep, only then waveform we can see it. Okay, and then only when you give some fixed time, it will execute and show you some fixed time output. Okay, this is about 2x1 multiplexer, very easy circuit. PN diode easy, 2x1 multiplexer also easy. This table we verified. Okay, next what I will do, in the same flow, you can take 4x1 multiplexer. You can try. Those who are familiar or those who got some confidence, you can just try 4x1 multiplexer. Where to take the components. Okay, take a new workspace. I will go with a new workspace. Okay, view library browser. View library browser. If you type MUX, all the 3 are available. I want 4x1 MUX. Drag and drop 4x1 MUX here. Escape button. Okay. Now 4 inputs are there, 2 selection lines are there. So that many square waveforms I want, and keep them appropriately without overlap. Here I will keep the first voltage. Okay, second voltage, third voltage, fourth voltage, selection line MSB, selection line LSB. Okay, give escape. Take the ground connection, give ground for all these voltages, ground connection for all the voltages. Okay, now we will give the name as per PPT. I will show you the PPT. The names are D0, D1, D2, D3. 4 input names are D0, D1, D2, D3. You can give it as VA, VB, VC, VD. Okay, voltage VA, VB, VC, VD. Selection line we will maintain S0, S1 as the names. Okay, selection line we will put SCL1, SCL2, otherwise S0, S1. Okay, so with this, I will go to the, first I will connect them. First voltage source for the first input, second voltage source for the second input, third one to the third input, fourth input, selection line MSB bit, LSB bit. Okay, so I think this is not coming, means it is not connected properly. I think it is okay. Now for output also, just I will drag and give some wire. Okay, I will just leave it and connect the resistor afterwards. Now give the names, double click the square wave. First one name is VA. Hit the display tick mark. Okay, and then here duty cycle I will give it as 1.0. Duty cycle for first waveform I will give it as 1.0. Duty cycle for first waveform. Okay, then second waveform I will take the name as VB. Display I want. Duty cycle I will take it as 0.75. 0.75. Is it okay? 0.75. Next, the third one I will give the name as VC. I want display. Duty cycle I will take 0.5. 0.5 for the third one. And the fourth one, if it is half, it will be good. Okay, duty cycle. Just I will come back to the duty cycle. VD, I want the display. Okay, so I will make double of this, 2.5. I am putting VD duty cycle 0.25. VD duty cycle 0.25. For VC, I will take 0.5. For VB, I will take 1.0. 1.0 for VB. And for VA, I will take 2.0. 2.0 duty cycle. Okay, so double. VD is the basic 0.25. Then I doubled 0.5, doubled 1.0, doubled 2.0. That is the duty cycle I am maintaining. So that to get all the 16 combinations, 4 inputs are there. So I want 4 zeros to 4 1 combinations in the input. You can see the truth table. You can see the truth table. Okay, all combinations if I want to check. Okay, that is the thing. So I have given like that. Then the selection line, I will give the name for first selection MSB bit selection line as S1. S1 as the name, and click on this display. Duty cycle, let it be 0.5 and the other one be 0.25. Okay, so here 0.5 first selection line duty cycle. Second one I am giving name. Second one I am giving name as S0. LSB S0. I want the display, and the duty cycle I am giving 0.25. Okay, I will repeat once again. I have given names VA, VB, VC, VD, and the selection lines, this one S1, and S0. S1, S0. You can see here in the PPT, S1 is MSB bit, S0 is on the LSB bit, lower bit is S0, most significant bit is S1. Okay, that names I maintained, S0, S1. Then VA, VB, VC, VD are input lines. And VD I have fixed 0.25 duty cycle. VD I have fixed 0.25 duty cycle. Then VC is double to the 0.25, which is 0.5 duty cycle. Next one is double for previous. Okay, now this is 1.0. Next one is double for this. So 2.0. Okay, like that I have given. And duty cycle for S1 I have taken 0.5. Duty cycle for S1 I have taken 0.5. S0 I have taken 0.25. S0 I have taken duty cycle 0.25. Okay, so I want combinations for S1, S0, 4 combinations, 0001, 1011. That's why I have taken duty cycle like that. So S0, S1, 4 combinations I want, 0001, 1011. That's why duty cycle I have taken. One is half for the other. Okay, so circuit is okay, and here it is floating. So I will take a resistor and connect. Select the resistor, rotate, okay, and then connect a ground also here, connect a ground, and then give wiring. Okay, now I want to see the waveforms, so I will take probes. This is the voltage probe, I will put it for VA, one probe, VB waveform, another probe, VC, VD waveform. Okay, one is for first selection line, next is for second selection line, and for the output. So many probes. Okay, anyway we will give the name, so no confusion. Here I will give wiring for the first selection line. The probe I am just connecting with this extra wire, and S0 selection line I am connecting with the extra wire. Now give names for the probes. Okay, don't get them display. This is VA, no need of display. Next probe is VB. In the waveform window, these names only will come. So we are changing to the same names as voltage source. Then third one VC, and the fourth one VD. Okay, and this first selection line MSB bit, we will give S1, same name. Okay, name will not affect the working of probe. As we like, we can give the names. This is S1 probe, and this probe S0 probe, LSB probe. Okay, LSB selection line. For output, if you don't give any name also, we can remember. Okay, all other probes we have given name, only this is the output, or give V out. Okay, V7 or V out. My circuit is completed. Now I want simulation control. Drag and drop onto the workspace. Okay, I will give 0.002. 0.002. Let me try. This is trial and error only to see all the combinations. That is our intention. Okay, 002 or 001, anything you give, simulation control, how long it has to be executed. Circuit should be executed. Now I am going to the run simulation. Error message VA, somewhere it is not connected. Finding error. So this probe is not okay, I think. I will connect one more time from the first input. This green color probe is there. Okay. I think error will keep on coming. There should be some distance between the wiring should be green color. Okay, wherever green color is not there, that wiring is not proper. Okay, I have many places where green waveform color wiring is not. So in your drawing also, if you have faced any problem like this, so kindly correct. Anyone drawn the circuit completely? Okay, with green color. Output is coming, you can just inform us. We will allow you to share the screen.
Ma'am, we need to change the duty cycle of first probe.
First probe duty cycle.
Yes, ma'am.
Then it is coming.
It give the error message that it must be values 0 and between 1. We given 2.
Oh, between, yes, correct. Correct. Duty cycle means on time by total time. It is 100% correct, 0 to 1. Okay. So what I will do, just 1 minute. You take it as 0.5, 0.25, half of that means 0.125, half of that means 0.675, something like that. Okay. Yes, correct. The mistake is with the duty cycle only. Duty cycle means on time by total time. So it cannot be greater than 1. So what I will do, the maximum one, I will put 0.5. This is okay. Next one, I will put 0.25. Name also I have to change, VB. Next one, half of that, 25 half is 12.5. 25 half is 12.5. And this is third input. This is third input. Okay. And 12.5, half of 12.5 is 6.75. 6.75. 0.06. I have to put 0.675. Okay. 12.5, half is 6.75. And this is VD. This is VD. Okay. And now this VA name I didn't change. So finally, I will make a check. VA 0.5. VB 0.25, half of that. VC 0.125. 25 half is 12.5. 12 point half is 0.675. Okay. And then probe. And this one, these are just a trial to see for proper visibility of the waveform. What we are doing is proper visibility of the waveform. If we drag and drop as it is for all the voltages 0.5 as the duty cycle, okay, it would have executed. Without error, it would have executed. If I am not changing any duty cycle and simply drag and drop, all of them having 0.5 duty cycle, it will execute. Okay. But the combinations in the output waveform will not be able to see it properly. Okay. So otherwise, this is okay, 0.5, 0.25. less than 1. Okay, now I will try to simulate taking this as 0.002. I will just simulate. This is run simulation. I want V7 final output. First, selection line, let it come at the bottom. Okay, selection line, let it be the last one. And the first input is VA. First input is VA. Then second input is VB. Third input VC. And fourth input. And then selection line MSB bit. You should give MSB bit first. Then LSB bit S0. Okay, 6 plus 7 waveforms are there. 7 waveforms are there. Okay, 7 waveforms. This is S0, S1. S0, S1. 1, 1. Combination 1, 1 means fourth input should come at the output. You can see the truth table. 1, 1 means, okay, last input should travel to the output. 0, 0 means first input should travel to the output. 0, 1 means second input. 1, 0 means third input. Okay, 0, 0, 0, 1, 1, 0, 1, 1. Here we have 1, 1. 1, 1 means fourth input should travel to the output. This is the fourth input. Okay, it is coming at the output. Okay, next combination, here we have 1, 0. 1, 0 means third input. 1, 0 means third input. Third input is 0. Only we can see up to this duration only, where the selection line is 1, 0. Where the selection line is 1, 0. Okay, this position. From here, the selection line is 1. Okay, 1, 0 means third input. 0, output is also 0. 0 combination in the selection line. 0 combination for the selection line, which means first input should come at the output. This is the first input. Okay, same vertically we have to check. Okay, first input 0, so output also 0. Next we have 1, 1 again, 1, 0 again, 0, 0. 0, 1 combination didn't come. 0, 1 combination didn't come. Okay, so for to see that what we can do, duty cycle only we have to vary so that that 0, 1 combination should be available. 0, 1 combination should be available. Okay, so for that just one change I will try. In the S0, instead of 0.25, I will put, instead of 0.25, I will put 12.5, 0.125. Now in the output waveform, I expect that 0, 1 combination also. Again, I have to, same order I have to select. First is VA. If you make zigzag while analyzing, it will be lot of headache. Okay, so we have to maintain some order so that for analyzing it will be easy for us. Waveform will come correctly because multiplexer is inbuilt component we are taking as it is. We didn't do anything inside the multiplexer. It is 100% working component available. Okay, so output will come 100% correct. Only we faced the problem, duty cycle we gave wrong. That's why. Okay. So 0, 1 combination earlier it was not there. Now also 0, 1 combination not there. 1, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, 0 only available. If I change, if I maintain this as 0.5 and change this as 0.0675. Okay, let me try. When you maximize, it will be visible. Okay. So 0, 1 combination is now available. Okay. So 1, 1 is there, 0, 1 is there, 0, 0 is there. 1, 0 is not possible here. Okay. So 1, 0 anyway we analyzed previous. No. 0, 1 we will see. 0, 1 means second input should come at the output. Second input is VB. Second input is VB. You can see 0, 1 combination from here to here. Selection line 0, 1 combination starts from here to here. So for this entire period, whatever second input is there, second input high here, output is high here. Second input slowly coming down, output also coming down. Second input is 0 up to this point, output also 0 up to this point. Second input should travel to the output, okay, when the selection line is 0, 1. Okay, so I have given you enough idea. I think you can play game with this circuit, okay, whichever fashion you want. You can change the duty cycle and analyze to truth table.